All right, guys, since I'm not at school today, I am going to go over the notes with you virtually. So please watch the video, take down the notes on your introduction to module 7 paper that you were handed out by the sub, and then work on either the quizzes that I'll post soon or work on ALEKS topics. All right. So we should all know what an exponent is, but just a quick review. An exponent is a number telling you how many times to multiply a number by itself. The base is the number being multiplied by itself. So this is a base and an exponent. This larger number is considered your base, and the small number up above is your exponent. This should all be review from previous classes. So there are some patterns with exponents that can help us remember what to do with them. So if we have 5 to the third, that's the same thing as having 5 times 5 times 5. So that's equal to 125. If we have 5 to the second, then we have 5 times 5, which is equal to 25. You'll notice here to go from 125 to 5, what I really did was divide by 5. 5 to the 1 power is just 5. That's really our identity exponent rule. And that is equal to 5. Again, to go from 25 to 5, you'll notice that I divided by 5. So we should be noticing a pattern. Okay, 5 to the 0 power is going to equal 1. And that's because we had 5. When 5 was to the first power, it was 5. And to go to the next exponent below, we're going to divide by 5. And 5 divided by 5 is 1. So really, any exponent to the 0 power will always, always, always be 1. There is no exception. 5 to the negative 1, we end up with 1 over 5 because, again, what we're doing is we are dividing by 5 at each step. So if I have 1 and I'm dividing by 5, then I get 1/5. And so the pattern is going to continue. 5 to the negative 2 power is 1 over 5 times 5, which is equal to 25. And again, all I did was continue to divide by 5. 5 to the negative 1/3 is 1 over 5 times 5 times 5, which is equal to 1 over 125. So we should see that as our exponents are increasing, we are multiplying by another 5. And as they are decreasing, we are actually dividing by 5. So that's the same for any case, whether it's a number or a variable, there is a pattern to our exponents. Okay, so this is a quick review. This was posted for your due now. You should have already completed your quick check, but if you did it and you didn't get it all correct, let's review the correct answers. So 4 times 4 times 4 times 4 times 4, there's 5 fours, 1, 2, 3, 4, 5, is just 4 to the 5th. X times x times x is x to the third. I do see some students usually write that as 3x. No, that would be x plus x plus x. So be careful not to make that mistake. M times n times p times p times p times p times p. Well, that's m to the third, p to the 5th. And then we have 1/5 to the 6th. 2 to the 6th power simplifies to 64. Don't worry, next week I will show you how to do this in a calculator if you don't already know how to. Negative 5 squared, well, because I have a negative multiplied by a negative, I get a positive number, so it's positive 25. 1/2 to the 4th power is going to be 1 to the 16th power, or 1 to the 16th, 1/16th, goodness. And negative 4 to the 3rd power is negative 4 times negative 4 times negative 4, which is equal to negative 64. Because yes, a negative times a negative makes a positive, but then when I have a positive times a negative, I end up back with a negative. So be careful with your signs if you have an odd exponent. All right, so let's review our exponent rules. And you should have learned all of these previously in your other math classes. Okay, so your product of powers rule is if you have two bases that are the same. So see here that we have a times a. If our bases are the same, we add, and we're multiplying, we're going to add the exponents. So we have 3 to the second power times 3 to the fifth power. We add 2 plus 5, and we get 3 to the seventh power. Our quotient of powers, when we have the same bases, different exponents, or it doesn't matter if we have different exponents, but if we have the same bases and we're dividing, we're going to subtract the exponents. So 4 to the sixth power over 4 to the fourth power is the same as having 4 to the sixth minus 4 power, which is equal to 4 to the second power. All right. Here we have our power to a power rule, a to the m to the n power. Well, this means I'm taking this base and this exponent to this many powers. So I'm actually then going to multiply the two powers together. So I get 5 squared to the third power. I'm going to multiply 2 times 3, and then I get 6. So it becomes 5 to the sixth power. Power of a product. This just means that I'm going to distribute that exponent to each term that's in the parentheses. So I distribute the 4 to the 3 and the 4 to the 2, and then I get 3 to the fourth times 2 to the fourth. And power of a quotient. Again, I'm just distributing that exponent to both terms in the parentheses. So 3 over 4 to the fifth power is equivalent to 3 to the fifth and 4 to the fifth. All right, our negative exponent. When we have a negative exponent like we do here, you cannot leave your answer with a negative exponent. That's not simplified. It's improper. So in order to fix that, we just have to rewrite it as a fraction. So a to the negative 2 power becomes 1 over a squared. So here's an example. We have 5 to the negative fourth power. All we're going to do is write that as 1 over 5 to the fourth. Then that negative exponent, that negative number, goes away, and it just becomes positive. You just have to remember to write it as a fraction. Our identity exponent means if we have x, any number to the first power, or any number that's by itself that doesn't have a power listed, is really to the power of 1. And we have to remember that because if we just have a base that doesn't have an exponent, there's an implied 1 there. Our zero exponent property is my favorite because any number to the 0 power is 1. Any number or variable to the 0 power is 1. So I could have ABCD in parentheses to the 0 power, and it's going to be 0, and it's going to be 1. Okay? Anything to the 0 power is 1, because remember, when we're at the 0 power, we're taking this number, whatever number or base it is, and dividing it by itself. Our rational exponents, okay? We have a rational exponent is an exponent that is a fraction. So we have our denominator, the 3, and our numerator, the 2. So the bottom stays out, the top goes in. All right. So if the bottom stays out, that means that that's outside the house. The top goes inside the radical. So here's what that would look like with a regular base. And then here it is in another version. These two examples are equivalent. All right, that's it for our notes. I'll see you on Monday.